So those are just some details about using templates. So finally, I want to wrap up with an example of a templatized basic linked list, the actual implementation, but we will discuss how to do this using unique pointers to reinforce those ideas. Okay, so in our class we have our struct for our items, and you'll notice that we have the template keyword type name T, and here you'll notice that we are using the type for our value, and we're also using a unique pointer, and we are passing to it the item with the angle brackets for the type. So we want a unique pointer to the next item in our linked list. Now for our linked list basic class, again, it is using templates. So we have the keyword template, angle bracket, type name T, and our private data now will be a unique pointer to an item, and we have to pass the type of the item called head and just an integer for the size. And then our public functions are just going to be the constructor, the destructor, empty, which will return true if and only if the linked list has no members, size, which will just return the number of elements of the items in the linked list, prepend, and get. So prepend, we will pass it a value of the type of the items in our structs, and then we will add that to the front, this new item to the front of our linked list, and then get, given a location, we return the item, a reference to the item at that location. So let's see what the implementation looks like. First, for the destructor, all we need to do is while head. So what this is doing is while we have elements on the list, while head is not the null pointer, we move the next element into the head pointer. And when we do that, we would have deallocated the memory for the item that was the head, and the item struct will be destroyed for that. Now for prepend, you'll notice that we are passing in an item by const reference of the type of we're passing as a parameter. So then we have that would be the value. So the first thing we want to do is we want to make sure that we save the old head. So we declare a unique pointer called old head, and we move the item that was the head into it. Then we have to create our new item that we're adding to the front of our linked list. And the way that we do this is we call make unique, and we don't have to pass anything to the constructor for that. So we make a unique pointer to a new item of the types that were created, and then we just have to initialize the values. So we initialize the value head of the new head to be the value passed in as parameter, and then we initialize the value of the next pointer of the new head to be the old head. So this is, you'll notice that we are moving the old head to be set to the next of the new head, and then we increment the size. So I just wanted to illustrate that in this example we were careful with when we were defining our functions to make sure we had template and the angle brackets type name T before the definitions, and then we made sure that we used the name of the class, which is linked list basic, angle brackets with the type passed as parameter, scoping operator, and we did this for both of our functions, that we were careful to use the full scoping operator when we were defining our functions. Now finally, if we want to implement get, we will once again declare this function, or really define the function. We're careful to make sure we put template, angle bracket, type name T, and you'll notice that we use the full scoping operator, which is linked list basic, the angle brackets, T, and the scoping operator. The name of our function is get. We pass in a location, and we are returning a reference to the type of value items that are in the struct. Now, we don't do any error checking in this implementation, and that can be fixed, for example, with exceptions. For example, if our linked list happens to be empty, there's not going to be anything to return, or if someone gives a location which is beyond the size of the linked list. So that's something you can think about how you might want to fix. And so you'll notice here that we are not using a smart pointer. We're not using a unique pointer. And the reason for this is we don't really need one because we're just traversing the linked list. And recall that we cannot copy or assign unique pointers, and just traversing a list doesn't necessarily have anything to do with ownership. So here we are just using a traditional pointer. And when we use the traditional pointer, you'll notice that's just item, angle brackets with the T inside, with the star to indicate that it's pointer temp. And here we're taking the head unique pointer and we're calling get on it. That will return the raw pointer for the head. And now you'll notice that the code for traversing the linked list is precisely as we've seen it in the past. So while the pointer to the current item in the linked list is not equal to null, and loc is not equal to 0, so we haven't reached the proper location yet into the linked list, we just update the pointer. So we take temp will now equal temp next, but you'll notice temp next is a unique pointer. To get the raw pointer, we have to use the get function on the unique pointer, and that will return the address of the next item in the linked list. And as we do that, we decrement the location because we are going to keep on iterating through the list until we hit the location, and once we have, we return the value at that location. So as I mentioned to you, this is a good exercise to add error checking. Now if we want to use our templatized linked list basic, you can see inside main we declare a linked list basic of integers, and we add to the front the integers from starting from 9 going down to 0. So here we can have them in order in the list, and we just print out the size, and then we just print out each of the integers in the linked list. And this, as I had mentioned to you before, is one of those prime examples which is not very efficient way to do get, because we're traversing I steps to get to the ith element in the linked list. So this for loop in main is not very efficient, but it does print out each element in the linked list. It just takes O of n squared, where n are the number of elements in the linked list, whereas if we used an iterator and had defined one, we can do that in linear time.